Hello all, let us discuss a problem from LeetCode quickly, and we'll try to understand the problem and see how can we solve it. So this is a problem called even or tree, and below here the requirement of even or tree is given. So we need to return true if the given tree is even or tree. So the conditions are for every even index level. So we start from level 0 and we'll go to level 1. So level 0 is a even index level, and for a particular even index level, all the nodes should have odd value, and which should be strictly increasing order from left to right. Means starting from the left, this is a even integer level 2, and this all the values of this node should be odd, and it should be increasing order. Means after 3 we can have more than 3 in this even level. If we have for say 2 or 1, it will not valid, because if it's true is already violating one condition, which is a for a even level we can have only odd node, and 2 which is decreasing from it, so it will violate the requirement. For odd index it is vice versa. We should have even integer value, and it should have strictly decreasing. Means starting from left, if it's a 10, then we can have 8, 6 something. We cannot have more than 10 in the next right child. Okay, so let us quickly go over. I have made a note here. So as we have discussed, so as we have discussed, the problem is the root of binary tree level 0, even index will have odd, and so these are the requirement. And we see the root node will have always have level 0, means even, then it will have odd, then even, then odd. So we see that it will toggle between even odd, so it will start from even. So we can use a flag to determine the level. So for a particular even level, the node should be odd. Okay, so I have made a I make a note here. For or even level, we need odd node, and the value should be strictly increasing. So how we'll approach this problem is we can use simple BFS here. So how BFS will help? As we know, BFS will traverse the tree in a breadth-first manner, which is level order traversal, and it will use a queue internally, and just it will put the node into the queue, and put all the node for a particular level in the queue, and we'll see for a particular level, for say it's a odd level, means we'll have a flag set for that particular level, and we'll check the nodes if it's increasing order by comparing the previous value from it. So if it's a odd, and we know from the odd level we should have decreasing value, so the previous value should be more than the current value. Okay, so now we'll go over the code. You can ask in the comments if any doubt in the approach. I think it will be pretty easy. Those who know the algorithm, those who don't know the algorithm, you can comment down, and I can make a video on the BFS. Okay, so this is the approach. Just we need to while traversing in the current level, we just need to check the conditions, like the node should be given as a particular level, means it should be even for odd level, and it should be odd for even level, and the order we need to see by looking into the previous node. So when we see any violation of this condition, we'll simply return false. Will not wait till we return false. So after traversing all the node, if we don't return false, finally we'll return true. That means this tree is a even odd tree. So I have already implemented the solution. Let us go over the code. So as you see from the code, we are giving a root node. We'll check if it's null or not. If it's null, we'll return true, means no node is there, and so it's even or tree. We'll use a queue. So I'll go like, as we know, queue is a data structure which adds a node in the front of a queue, and it will pop from the front and push from the end. So this is the front of the queue. So for a particular time, all the same level node will be pushed together. So once it's pushed, we can traverse this node, and this is how we'll level order traversal is achieved using a queue. Okay. Now we go over the uh, approach and the solution we did in C++. So as discussed, we'll use a queue for the breadth first search, and we use a flag even, which is true if it's a even node, means even level, and which is false if it's a odd level. So starting from 0, the root will be always even, so we'll make it as true, and we'll use a while loop to see until we to traverse the tree until the queue is empty. So we'll push the root node first, and only at this level 0, which is even level, we have this root. So we come here, and the size we'll get for a particular level. So currently the size is 1 for the root, and the previous value will define it for even. We know the order for the even node should be strictly increasing, so we should have a minimum. It should be greater than the minimum, right? So previous value will be minimum for even node and maximum for odd node. Okay, so I think this even will make more confusing. You can use any other flag for true, for odd, and false for even, anything you want to use. But for me, I have added even, so if it's true means even and false means odd. Okay, so once we have the size of a current level, we'll just loop over the nodes. We'll take the from the front and pop it, and if it's a even, we check if the node value should not be even, and the previous it should be if the current node value is less than and equal, means it is decreasing from the previous value, then we have a problem, because the for the even node it should be strictly increasing, right? But we are getting the current node is, we are getting it less than equal to, means it is decreasing, so we'll simply return false. Similarly, if it's a odd level, we have this check for a odd case. If it's a we know the order should be strictly decreasing, so if we have the current node is more than the previous val, which is from the previous node of the current level, so if it's greater than equal to the previous val, so there is a problem, so we return false. So again we add if there is any child of a current node, front node, to the queue. So for the next iteration, it will take into the consideration, so we'll update the previous val to the current val. So once we do this for a current level, we make the event as false, means starting event is true for even level, and we make it false for odd level. So now the event will be false, and we'll take this condition, and this will go until we have all the nodes are already traversed. And if we don't return from here, means we are not violating any check, will simply return true, means it is a even or tree. So I think this is a simple problem, those who know breadth first search, and which can be simply implemented using few flags and few checks given in the problem. And by observing it, we only use BFS, nothing else. So yeah, that's about the problem. You can comment down below if you have any question on it. Thank you.